In the previous video, we saw the proof that convergence of the absolute value of terms implies the convergence of the series. So here's an example of that. Let's say you have this series right here, and it sort of alternates in the sign of it, because when n equals 1, negative 1 to the first power is negative 1 over 1 cubed is 1, so it's negative 1 right here. When n cranks up to 2, negative 1 squared up here will be positive 1 divided by 2 cubed, which is 8. So you're here. And so forth. When n is 3, negative 1 to the third power is negative 1. And so you'll have the negative here, and you'll have 1 over 3 cubed, which is 27, and so forth. So you really don't know what's going to happen to that series, but let's see if it converges by taking the absolute value of each of the terms right here and see what that series does. So you know that the absolute value of negative 1 to the n, that's either going to be negative 1 or 1 in there, so the absolute value will always just be the positive 1, and that's over to n cubed, which is positive since n is 1 or greater. So that means that this absolute term series is going to equal this one, which we know converges because it's a p series with p greater than 1, that 3 is greater than 1. Thus a series of absolute values converges, and then by the theorem that we saw in the previous video, therefore the series of the original terms converges.